Hello, I'm Brian Farrell, and welcome to PACE IT's session on Introduction to the BIOS. Today I'm going to give you some BIOS basics. We're going to access a BIOS, and then we'll talk about how to update a BIOS. And with that, let's go ahead and begin this session. So of course, we begin with BIOS basics. So what are the basics of BIOS? Let's begin with what the BIOS is. BIOS stands for Basic Input-Output System. It is the first software to run on a PC when the power is turned on. It is actually a firmware software that establishes the base behavior of the PC. It sets the hardware configuration of the system. It tells the PC what hardware to initialize and what the priority of that hardware is. It also points the PC to the files that are needed to boot the operating system. Now, BIOS is stored in non-volatile random access memory, NVRAM. That's a special type of memory that doesn't require an electrical charge to keep what's in the memory. It is designed and coded for the specific motherboard that it resides on. BIOS updates can add functionality to a system that wasn't originally present when the motherboard was installed. Now let's move on to how to access the BIOS. So why might you need to access the BIOS? Well, system stability may have been compromised by the addition of new components. Some people, gamers, adjust settings in the BIOS to improve performance. More importantly, the BIOS may need to be entered in order to help in the system recovery process. You know that brother-in-law of yours that is always got his PC infected? He called you up to seek your help. His computer won't even boot now. Well, you can resolve that issue if you can get into BIOS. So let's access a BIOS now. Now, for the purposes of this demonstration on how to access the BIOS, I'm going to be using a virtual machine, a VM, that's on my laptop. Now, the BIOS for this virtual machine is pretty basic, but it will work for the purposes of this demonstration. So let's go ahead and fire up this virtual machine. The first thing that you need to know about accessing a BIOS is how to do it. And in this case, I need to hit the delete key during the post, the power on self-test. Different BIOSes may have a different method of accessing. Some of them require that you hit the delete key, some the F2 key, and there are other combinations out there. It's up to the manufacturer of the BIOS to set it. So here we are on the main page of the BIOS setup utility. Let me get this centered a little bit better. So here we are on the main page of the BIOS setup utility for this virtual machine. The first thing that you should notice is that the manufacturer of this BIOS is AMI. They're one of the main manufacturers of it. And this BIOS is version 8.00.02, and it was built on August 14th, 2009. It is not the most current version of BIOS. Now, in most cases, when you access your BIOS, you're not going to have access to your mouse because it hasn't been initialized yet. So you have to use your arrow keys in order to navigate. Now let's take care of your brother-in-law's problem. Remember, he can't boot. He's gotten his system so infected it will no longer boot. So we would arrow over to the boot tab and take a look at the boot priority. The boot priority in this virtual machine is to look for the hard drive first and then to look for a CD-ROM. With this information, I could create a system recovery utility CD-ROM that was bootable and reset the priority so that it would boot to the CD-ROM first, so I could clean up my brother-in-law's system and then get him going again. There is a ton of information that is available to you in the BIOS. Now, this is a pretty basic BIOS, so I can't show it all to you. As a matter of fact, I can't show most of this to you. But quite often you have system configuration information. Not only the boot sequence, but also device status And things like system speed, that's your clock speed, whether or not you have virtualization support, and you also have BIOS security. Now this one does have BIOS security. I could put in a password here that would prevent my brother-in-law from changing my BIOS settings on his system to keep him out of it and to make it easier for me to fix it the next time. A lot of BIOSes also have monitoring capability. They can tell you what the temperature is inside your case and what the temperature of your CPU is. You can also see fan speeds on a lot of BIOSes and adjust those speeds. A lot of BIOSes also have built-in diagnostic information and the ability to use that information to tweak your system. But now that we've used your system's recovery utility disk and fixed your brother-in-law's computer, let's exit out of here. If you notice, we have to save the configuration, by the way. And if everything worked right, then we're back up and running. And voila, your brother-in-law's system's running it once again. Now let's move on to how to update the BIOS. Before I begin talking about the how to update a BIOS, I need to issue a warning. The BIOS is required in order for the system to boot. Making a mistake while updating the BIOS may have serious consequences for your system. You may not be able to boot. So let's talk briefly about why the BIOS may need to be updated. Well, you can extend the productive life of a system by adding additional functionality to the system by updating the BIOS. You also might need to update the BIOS to resolve issues that were unknown at the time that the BIOS was created. So what is the specific process required to update the BIOS? Well, the motherboard or system manufacturer is responsible for developing the BIOS update process for each motherboard. So in order to update the BIOS, you need to follow the manufacturer's instructions to the letter to avoid a catastrophic failure. Now that concludes this session on the introduction to the BIOS. I talked about BIOS basics. I talked about how to access BIOS, and I showed you accessing a BIOS. And then I briefly touched on how to update the BIOS. Now, on behalf of PACE IT, thank you for watching this session, and I'm sure another one will occur soon. Hello, I'm Brian Farrell, and welcome to PACE IT session on the introduction to the motherboard. Today we're going to be introducing the motherboard. We will also talk about different form factors and then some common factors of the motherboard. And with that, let's go ahead and begin this session. So let me begin by introducing the motherboard. The motherboard is the physical foundation layer for every system. The motherboard is also known by other names. It can be called the system board, the base board, the MB, or the MOBO. The motherboard, along with the BIOS, establishes what the system is and what components may be present. Some motherboards are very simple and some are very complex, but they all do basically the same thing. They lay the foundation for your system. And with that introduction, let's move on to different form factors of the motherboard. Now, the form factor of a motherboard is basically its size, and there are just a couple of main categories. There is the ATX. That is the basic form factor for a full-size, full-power PC. And the ATX size is 305 millimeters by 244. There's also the micro ATX. It's more compact in size, and it usually has a little less capabilities than the ATX. Now, sizes within the micro ATX may vary within a range. At its largest, an ATX motherboard can be 244 millimeters by 244, but it can also go down to 171.45 millimeters by 171.45. The next main form factor category is the ITX, which can also be called the mini ITX. Now this is a low power consuming form factor. It's even more compact than the micro ATX. The ITX form factor often doesn't require the use of a fan for system cooling. The standard size for an ITX motherboard is 170 millimeters by 170 millimeters. Now, a couple of special mentions on the ITX form factor are the Nano ITX and the Pico ITX. The Nano ITX is 120 millimeters by 120 millimeters, and the Pico is 10 millimeters by 7.2 millimeters. That's tiny. These tend to be used for specialty applications, and they're very low power consuming motherboards, but they also have very limited capabilities. Now let's move on to some factors that are common to almost all motherboards. And you notice that I put a caveat in that, and we get to begin with a disclaimer. As a general rule, these factors are present on all ATX and ITX motherboards, but it is up to the manufacturer to decide what is present and what is not. So what are these common factors? Well, they all have a spot for a CPU, for a central processing unit. All of them have spots for RAM. Some is removable, some are not. Almost all have chipsets, the North Bridge, South Bridge, and BIOS, although newer Intels don't require the North Bridge. They all have power slots. That's for the main power and in some cases for CPU auxiliary power. Some of the optional connections that are commonly found on motherboards are fan connectors, expansion slots, back panel connections, and front panel connections. Now, I said these are optional because they're not present on every single motherboard and are highly dependent upon the manufacturer. Now, that concludes this session on the motherboard. I introduced the motherboard. I talked about different form factors of the motherboard, and then I talked about some common factors of motherboards. Now, on behalf of PACE IT, thank you for watching this session, and I'm sure we'll do it again soon. Hello, I'm Brian Farrell, and welcome to PACE IT's session on random access memory. Today we're going to be introducing RAM, we're going to talk about different types of dynamic RAM, and then we will cover some special considerations of random access memory. And with that, let's go ahead and begin today's session. And of course, I'm going to begin by introducing RAM. When most people talk about computer memory, they're talking about dynamic random access memory, DRAM, not the St. Louis RAM. DRAM is not the only type of memory that is present, but it is the one that most people are familiar with. DRAM is used to hold data and pass it between the CPU and storage devices. We use dynamic random access memory because it's quicker and more responsive than using the storage device itself, and it can hold a lot more data than the CPU. We commonly refer to dynamic random access memory as RAM, random access memory. So how does RAM work? Well, it uses transistors and capacitors to hold electrical charges. Arrays of these transistors, called registers, the registers are either on or off. That's the binary 1 or 0. If there is no electricity, there is no memory. Now there are two basic types of RAM. And the first type is static RAM, SRAM. Static RAM is located on the CPU die or just off of it. It's commonly referred to as cache or cache memory. It's super fast, but it's also very expensive, so it's used in limited amounts. Dynamic RAM, on the other hand, is always located off the die. It's fast, but not as fast as static RAM. But it's also relatively inexpensive, so we can use a whole lot more of it. Now let's talk about types of dynamic RAM. And we begin with the dual inline memory module, the DIMM. Now the DIMM is both obsolete and cutting edge. Before the introduction of the DIMM, memory modules could only receive current through one side of their electrical contacts. This limited the memory bus to only being 32 bits wide. The DIMM could receive electrical current through both sides of the electrical contact, and the memory bus grew to 64 bits wide. All current RAM are types of DIMM. So now let's move on to synchronous dynamic RAM, SDRAM. This is the true beginnings of modern RAM. It was the industry standard beginning in 1993. It was synchronized with the system clock and could perform an operation with every cycle of the clock. It's currently considered obsolete. Why? Well, because it was replaced by DDR. Now, DDR was introduced in 1996, and it effectively doubled the possible rate of data transfer by taking advantage of the falling and rising edge of the clock cycle. That means that it could perform 2 operations per cycle. The speed of the RAM is determined by a specific formula. It's the clock rate times 2 times 64 divided by 8, and that gets you your megabyte transfer rate. Now, if Intel had had their way, DDR RAM would have been replaced by Rambus, dynamic random access memory. Now, Rambus was a proprietary standard developed by Rambus Inc. that was initially supported heavily by Intel. It had to be installed in pairs, or you had to use a special device called a continuity module, also called a RIM, in order for it to function. It was faster than DDR, but it was not as cost-effective as DDR, so it never really caught on. Now let's talk about DDR2 and DDR3. DDR2 doubled DDR's performance. The formula to figure out its transfer rate is clock rate times 4 times 64 divided by 8. That was superseded by DDR3, which doubled DDR2's performance and is the current standard. Its formula is clock rate times 8 times 64 divided by 8. Super fast. Soon we're going to see DDR4 and DDR5 being common, but not quite yet. Then there's small outline dual inline memory modules, SODIMM. This is compact memory modules that are used in small form factor computers, like laptops in most cases, and in tablets. Now, SODIMM can be DDR, DDR2, or DDR3, all depending upon the manufacturer. There's also parity and non-parity RAM. Parity RAM modules have an extra bit, a parity bit, that is used to check for errors in RAM. It can't fix the errors, but they can find it. It's more expensive than non-parity RAM, and it's not really needed anymore because applications check for errors now. Then there's error correcting code RAM, ECC RAM. ECC RAM can detect and recover from errors in memory. It's much more expensive than standard RAM, but it should be used in situations where an error can't be tolerated. Now there's another thing to consider about RAM. It can be dual-sided or it can be single-sided. Dual-sided RAM is when the memory modules on a stick are separated into ranks. Only one rank may be accessed at a time. Single-sided RAM, on the other side, is when memory modules are not separated into ranks. It is faster, but more expensive than dual-sided RAM. Now let's move on to some special considerations of RAM. This first consideration is single-channel versus multi-channel RAM. In single-channel RAM, all banks or slots of the RAM make up a single 64-bit bus to the CPU. In multi-channel RAM, the banks of RAM may be grouped together to form a wider bus to the CPU, and that bus may be 128 bits or 192 bits wide. To take advantage of the multi-channel abilities of the RAM must be installed in matched sets. And you need to follow the motherboard documentation when installing multi-channel RAM. You also need to know what type of RAM your motherboard supports. A motherboard will only support one type of RAM. You can't mix different types together. The RAM modules are keyed on the bottom so that they can't be placed into the wrong type of RAM slot. And the final thing that you need to consider, you can install different speeds of RAM together, but you need to remember that the RAM will only function at the speed of the slowest module. Now that concludes this session on random access memory. We talked about RAM, we talked about different types of RAM, and then some special considerations about RAM. Now on behalf of Pace IT, thank you for watching this session, and I'm sure I'll do another one soon. Hello, I'm Brian Farrell, and welcome to Pace IT's session on expansion cards. Today we're going to be talking about the why of expansion cards, different types of expansion cards, and then we'll cover the basic steps of expansion card installation. Now with that, let's go ahead and begin this session. So we're going to begin with the why of expansion cards. Well, thanks to the highly modular nature of the PC, expansion cards are a great way to increase the functionality or capabilities of a system. Expansion cards can extend that capability of the system by adding more resources. Expansion cards can increase the functionality by adding abilities that weren't in the original operating system. Expansion cards are often a fairly inexpensive solution to a multitude of issues that may occur. That is the why of expansion cards. Now let's briefly touch on different types of expansion cards. We're going to begin with sound cards. They expand the sound capabilities of your PC. They're popular with gamers and those who watch videos and/or television on their PCs. You can go from mono sound to stereo sound to surround sound with a sound card. Let's move on to video cards. Video cards can increase the overall performance of your system depending upon the card that you install. They can also add the ability to add multiple monitors. One of the ways that they increase performance is by taking the workload off of the CPU and transferring it to the video card. A good video card is a wise investment. Then there's network cards. Most motherboards have built-in network cards nowadays, but they can fail, or they might not connect to the right type of network in your situation. Or you might need to connect to another or different type of network, or make multiple network connections. That would be the reason to add an expansion card. Another reason to add expansion cards would be legacy applications. Most systems nowadays do not come with a serial or parallel port, but some applications and situations still call for those type of connections. You can add an expansion card that has a serial and or parallel port to your system. There are USB cards. You can add more USB ports to your system. You can also add newer versions of USB by using an expansion card. It's the same kind of situation with a FireWire card. You can add more FireWire to your system or just add FireWire to your system. And by installing an expansion card, you can update your system. There are expansion cards that help with storage. There are different storage solutions through expansion cards. So you need to add a SCSI tape array? Well, you can add a card that allows you to connect to a SCSI. There are also expansion cards that are solid state drives in their own right. They're really fast. They also tend to be fairly expensive though. They are a unique solution to storage. Let's talk about modems. Most systems don't come with built-in modems anymore either. It's kind of like the serial and parallel ports. But if you still need to connect to a legacy virtual private network, you're going to need that modem. That's where an expansion card that has a modem built into it will resolve that problem. There are wireless and cellular network cards. They allow you to take advantage of wireless networks. And a cellular card can take advantage of LTE or 4G networks, although caution, additional data charges may apply. A TV tuner card allows a PC to make a cable television connection. This is a popular option for the home theater PC. Cable television can be routed through or watched on the PC. Video capture cards are used to capture video images. Specialized cards are used to capture video and or still images that cross through the PC, and they may be combined with a TV tuner card. And finally, we're going to end with the riser card. This is an adapter for other cards. It plugs in and offers the ability to install another card at a 90-degree angle. You use a riser card when space is tight within the case. Now let's cover the basic steps of expansion card installation. Before we get started on the physical steps, there is some planning that's involved. The first thing that you need to determine is what you're trying to accomplish. There are often multiple ways to solve an issue. Which one is right for this situation? The next thing that you need to consider is there an open slot? It really doesn't do you much good if there's not. If there is not an open slot, then you need to make a decision. You need to decide on how to free up a slot or whether or not you need to go a different route. Next, is there enough physical space inside the case? Check the dimensions of the proposed card to make sure that it will fit inside the case. And finally, is there a better option? Do your research and plan for the future. It can often be less expensive to plan for the long run than to go a little less expensive but be hindered in your future use. Now let's move on to the physical steps. Step 1. You need to read the documentation that comes with the card. Specifically look for when the driver needs to be installed. Does it need to be installed before you insert the card or after you insert the card? Step 2. Power down and open the case. Make sure you follow all safety procedures. Step 3. Determine which slot you're going to use. If there's an open slot, install the card, making sure it is firmly seated. If you're going to install it into an occupied slot, remove the old card and then install the new one, making sure it's firmly seated. Then you close up the case and power up. Once the system is powered up, test for functionality. Make sure it works right. And finally, check the manufacturer's website. Often there's an updated driver or a firmware update that you want to install to make sure that you have all the functionality that is required. Now that concludes this session on expansion cards. We covered the why of expansion cards, we covered the types of expansion cards, and then I briefly touched on the basic steps of expansion card installation. Now on behalf of PACE IT, thank you for watching this session, and I'm sure I'll do another one soon. Hello, I'm Brian Farrell, and welcome to PACE IT session on storage devices, part 1. We're going to be talking about types of storage devices, and then I'm going to dive into SCSI storage devices, and then we'll talk about RAID. Now I have a whole ton of information to cover, so let's go ahead and get right in. So we'll truly begin this session with a discussion on types of storage devices. First up is the traditional internal hard disk drive. It's the spinning platter type of hard disk. It had two types of interfaces. It had the parallel AT attachment interface, the PATA interface, and the SATA interface, serial AT attachment interface. These are still very common in today's computers. Then we move on to the more non-traditional types of internal hard disk drive. There's the solid state drive, the SSD. There is the small computer system interface drive, the SCSI drive. And then there are RAID systems. Now I need to cover this, but you probably won't find these in a modern system, and that is the floppy disk drive. Floppy disk drives were first commercially successful with the 8-inch floppy. Now it is extremely obsolete now. It was replaced by the 5¼ inch floppy disk drive, but it too is also obsolete. It was replaced by the 3½ inch floppy, the most successful of all the floppy disk drives. Now they're not very common now, but you may still come across one in the workplace, so you need to know about them. They had a maximum capacity of 1.44 megabytes. So now let's move on to the CD-ROM, the compact disc read-only memory. When these first came out, they commonly used the PATA interface, but now more than likely you'll find them with the SATA interface. The CD-ROM has a maximum capacity of 700 megabytes. Originally, CDs could only be read from and not written to. But as technology advanced, guess what? Things changed. Now a CD-RW is a combo drive, also commonly known as a CD burner. It allows for writing data to the CD. And of course technology marches on, and we came up with the DVD-ROM, the digital video disc read-only memory. Now it has a maximum capacity of 4.7 gigabytes in its single layer format, and 8.5 gigabytes for a dual layer format DVD. Now DVDs also came out in the DVD-RW. Just like the CD-RW, it's a combo drive that allows for writing to the DVD. Then we have the BDR, the Blu-ray disc read. Its common internal interface is the SATA interface, and it has a maximum capacity that ranges from 25 gigabytes to 128 gigabytes for a 3-layer BDR. Now a BDRE is a combo drive that can write and erase data to the Blu-ray disc. Now let's talk about some external storage devices. As a general rule, all of the internal storage devices are available for an external connection. The only difference is that the interface tends to be different. Now, common external connections can be made through USB, Universal Serial Bus, or FireWire, the IEEE 1394 standard. And now we have what's called eSATA, External Serial AT Attachment, that some devices may also implement. Other types of external storage devices would be the network attached storage, the NAS. There's also the storage attached network, the SAN. More than likely, you will not find these in your average small office, home office, but you can find them in the enterprise environment. Then there are also cloud storage solutions, which tend to be a type of storage attached network. And as a rule, these all involve transferring your data over Ethernet. Now let's move on to SCSI. So we get to talk about the Small Computer System Interface, SCSI, and it was standardized in 1986. Now SCSI was not very popular in the home market because SCSI devices cost more than regular devices, and they are a little bit more difficult to manage than your standard storage device. But SCSI was very popular in the enterprise market because the devices were very robust and could be easily, well, fairly easily, chained together. When devices are chained together, the last device in the chain needs to be terminated in order to stop signal bounce. In order for the chain to work, the last device needed to be properly terminated. Now, SCSI's longevity has led to different versions being on the market at the same time. Another thing that you need to know about SCSI devices is that many of them were hot swappable, meaning that the system didn't need to be shut down in order for a defective device to be replaced and or for a new device to be added into the chain. Now there are two main iterations of SCSI. There's narrow SCSI. That means 8 total components could be chained together, 1 controller and 7 devices. And then there's wide SCSI. That's where 16 total components could be chained together. Again, 1 controller and then 15 devices. Now let's move on to RAID. RAID stands for Redundant Array of Inexpensive Disks. Now, RAID is taking multiple disks or storage volumes and combining them to achieve performance gains, or fault tolerance, or performance gains and fault tolerance. The first RAID that we're going to talk about is the RAID 0, also known as a stripe set. Now this requires a minimum of 2 volumes. Data is striped between the drives. Write a block of data to one volume, then write the next block of data to the other volume. Now RAID 0 offers the best performance out of all of the RAID types in most situations, but it is not fault tolerant. And what that means is that if one drive fails, the whole stripe set is ruined. To combat that, RAID 1 was developed. Now RAID 1 is also known as a mirror set. Now it too requires a minimum of 2 volumes, but the data is mirrored between the 2 drives. The system writes each block of data at least twice. Now RAID 1 offers extremely fast read times, but it's relatively slow in the write time as it needs to write twice. But it is fault tolerant. If one drives fail, the data is still safe. In an effort to improve RAID performance, RAID 5 was developed, and it can also be called striping with parity. Now RAID 5 requires a minimum of at least 3 drives. In a RAID 5 setup with 3 volumes, it stripes data across 2 drives and adds a parity block to the 3rd drive in a rotating manner. The parity block adds fault tolerance to the RAID. If any one disk fails, the data can still be rebuilt by combining the data on the other 2 disks and combining it with the remaining parity blocks. Now RAID 5 is not as fast as RAID 0, but offers better performance than RAID 1 while still providing fault tolerance. Now, if you have the ability, you might want to implement RAID 10, which is also called a stripe of mirrors, or it is sometimes referred to as RAID 1 plus 0. Now, that requires a minimum of at least 4 volumes, and it involves a mirror set that is also striped. Next to RAID 0, it offers the best performance, but it also offers a high degree of fault tolerance. Now that concludes this session on storage devices. We talked about types of storage devices. I briefly covered SCSI, and then we went into RAID a little bit. Now on behalf of PACE IT, thank you for watching this session, and I'll do another one soon. Hello, I'm Brian Farrell, and welcome to PACE IT's session on Storage Devices Part 2. Today we're going to discuss the anatomy of a hard disk drive, then we're going to talk about some aspects of the traditional hard disk drive, and then we're going to cover some items about solid-state drives. There's a fair amount of information to cover, so let's go ahead and begin this session. And of course, we begin by talking about the anatomy of a hard disk drive. So hard disk drives are composed of various components, including multiple metal disks that are called platters. These are held in place by a spindle which rotates the platter. Then there's the armature, which moves the read head across the platters to read and write data to the drive. Getting a little deeper into the anatomy of a hard disk drive, well, the platters are logically broken up into tracks. Think traffic lanes, in which the data is electromagnetically laid down. The tracks are logically broken up into sectors, think addresses, in order for the PC to know where the data is located. Now, the faster the platters spin, the faster the drive can read and write data. Common spin rates range from 5,400 RPM all the way up to 15,000 RPM. But in the consumer market, you're more likely to see the 5,400, the 7,200, or the 10,000 RPM hard drive. In the enterprise market, you're much more likely to come across the 10,000 RPM or the 15,000 RPM hard drive. So now let's move on to some other aspects of the traditional hard disk drive. And we're going to begin with its traditional interface to the motherboard, and that would be the parallel AT attachment, PATA. Now this could use either the Integrated Drive Electronics, IDE, or Extended Integrated Drive Electronics, EIDE, interface on the motherboard. The actual interface connection on the motherboard was a 40-pin connector. Now if the motherboard only supported IDE, a 40-wire, 40-pin ribbon cable was used to connect the hard drive to the motherboard. If the motherboard supported EIDE, an 80-wire, 40-pin ribbon cable was used, and higher transfer speeds were achieved. The maximum speed, or rate of transfer, of a PATA drive was 133 megabytes per second. Now, power was supplied to the hard drive through a 4-pin Molex plug. Now, with the PATA interface, a master-slave relationship was used to determine which hard drive was bootable when multiple devices were present on the same ribbon cable. The master-slave status could be set by jumpers on the back of the hard drive. With the introduction of EIDE, there was another relationship that could be chosen, and that would be cable select. And what that meant was where the device plugged into on the cable would determine if it was the master or the slave drive. Then along came serial AT attachment SATA. It can be used with traditional hard drives or with solid-state drives. Now it's a newer interface standard and it achieves much higher transfer rate. SATA 1.0 was capable of 1.5 gigabits per second transfers. SATA 2 was capable of 300 megabytes or 3 gigabits per second transfer, and SATA 3 has a theoretical transfer rate of 6 gigabits per second. Now on SATA, only one drive was allowed per cable, and your boot priority is no longer established at the drive, but it is set in the BIOS settings of the motherboard. Now the SATA interface uses an L-shaped connector with a 7-wire 7-pin cable. On an interesting note, all SATA drives are hot swappable, meaning that the PC and the device do not need to be powered down in order to replace it and put a new one in. But that's of limited value when the SATA drive is inside of your PC. Now let's move on to solid-state drives. Now, solid-state drives, or SSDs, use different construction altogether. There are no moving parts. They use arrays of flash-type memory instead of spinning platters to hold the data. You can achieve faster response times with an SSD than you could with a traditional hard drive. When an SSD is used internally, the most common interface is the SATA interface. When your solid-state drive is used externally, the connection type can vary. It can be USB, or it can be eSATA, or it could be FireWire. They are faster and quieter and cooler than the traditional hard drive, but the price per gigabit of storage is much higher than with traditional hard drive. So they're not going to replace the traditional spinning platter hard drive soon, at least not until the price comes down a bit. Now, some devices are a type of solid-state drive, but they're not really considered a solid-state drive. And what are those? Well, there's compact flash. Now, compact flash is a type of removable storage. It could be considered a solid-state drive because it holds data and there are no moving parts. Now, with compact flash, you can hold up to 128 gigabytes of data. Then there are secure digital cards, SD cards, with a current max capacity of 2 terabytes of data. We also have the older XD standard. Now this was used in some digital cameras to hold pictures, but is now considered obsolete. Now USB flash drives could also fall into the SSD category, but not really, because people think of them as their own category. Now that concludes this session on storage devices part 2. We talked about the anatomy of a hard disk drive. We talked about some aspects of the traditional hard disk drive, and then we briefly touched on solid state drives. Now, on behalf of PACE IT, thank you for watching this session, and I'm sure another one will happen soon. Hello, I'm Brian Farrell, and welcome to PACE IT's session on the Introduction to the CPU. Today we're going to discuss CPU basics, Intel and AMD CPUs, and then we'll try and answer the question of which one is right for you. Now with that, let's go ahead and begin this session. So let's begin with some of the basics of the CPU. According to Moore's law, the number of transistors on an integrated circuit will double approximately every 2 years. This creates an exponential growth in the power of the integrated circuit. Now, Moore's Law was introduced back in the 60s, and it still pretty much holds true for today's CPUs. So now let's talk about the central processing unit, the CPU. The first characteristic of it is speed. Now, speed typically is the frequency at which one core of the CPU operates. Currently, it's measured in gigahertz per second. The higher the number, the faster the core. Now let's talk about the cores. Now, the cores are the actual CPU on a chip, on a silicon wafer. If a CPU is a multi-core CPU, then it actually has multiple CPUs on the same chip. The more cores, the more simultaneous tasks that can be accomplished. Then there's cache. Cache is expensive static random access memory that is located on the CPU die. All cache memory is much more expensive than regular dynamic random access memory, so not much of it is used. Cache is broken into 3 levels. L1 cache is typically embedded in each core of the CPU. L2 cache is typically located just off of the CPU or embedded into a coprocessor. L3 cache is still on the CPU die, but it's a little bit slower than L1 or L2 cache. Now let's move on to hyperthreading. Hyperthreading is the logical division of a CPU core. Through special instruction sets, the CPU is made to look and behave as if it had more than a single core. So you could have a 2-core processor that had hyperthreading, and it would actually behave like it was a 4-core processor. Some CPUs have virtualization support. When virtualization began, it always required fairly complex software and a host operating system. CPU manufacturers have now built virtualization support into some of their processors. This allows for easier and less complex virtualization. Some more modern CPUs are now coming with a GPU, a graphics processing unit, on the die. This allows for decent integrated graphics performance while not hindering the basic operation of the CPU. So you don't have to buy a graphics card and your CPU performance is not hindered by graphics rendering. Last but not least under the CPU basics is the architecture. Now this is either 32-bit or 64-bit. This deals with the amount of memory that a CPU can address, that is, keep track of. A CPU that has a 32-bit architecture can only address a maximum of 4 gigabytes of RAM, while a CPU that has a 64-bit architecture can address a theoretical maximum of 16.8 million terabytes of RAM. Man, that is just a ton of RAM. In actuality, the maximum amount of RAM that a 64-bit system can handle is established by the motherboard manufacturer. And before we leave CPU basics, let's talk about cooling. As a rule, the higher the performance of the CPU, the more heat it will generate. Excessive heat will kill or burn out a CPU. Heat is your enemy. To combat that, there are heat sinks. A heat sink is a device that is placed on top of the CPU. It usually has a solid metal base, but it transitions to fins towards the top. A heat sink will draw heat away from the surface of the CPU towards the top of the sink where it is radiated away into the case. To help improve the efficiency of the heatsink, we use thermal paste. It's a special compound that is used between the CPU and the heatsink. It fills in the microscopic voids that are present and will improve the connection between the heatsink and the CPU, thus improving the heatsink's performance. Fans are used to help radiate the heat away from the heatsink. They are designed to draw cooler air across the fins, thus transferring the heat away from it. And finally, there's liquid-based cooling. This works kind of like a car's radiator. The heatsink actually has liquid being pumped through it to draw heat away from the CPU. The liquid gets pumped to a radiator where the heat is dissipated. Now let's move on to Intel and AMD CPUs. We're going to start with Intel because they're the granddaddy. Intel currently uses Land Grid Array CPUs, LGA CPUs. The CPU does not have pins on the bottom of the chip. The pins are actually located in the CPU socket on the motherboard. The CPU just has corresponding contact points on the bottom of the processor. Intel processors are usually defined by their processor family, like Haswell or Ivy Trail, and their socket type. Some Intel socket types are the LGA 775, the LGA 1155, the LGA 1156, and the LGA 1366. There are many more Intel socket types, and more are being introduced all the time. Now let's move on to Intel's main competitor, AMD. Most AMD CPUs are pin grid array CPUs, PGA CPUs. The CPU has pins on the bottom that fit into holes on the socket. AMD's naming convention is also based on processor family and socket type as well. Some AMD socket types that you'll see are the 940, the AM2, the AM2 Plus, the AM3, the AM3 Plus, the FM1, and the F. As with Intel, this is not a comprehensive listing, plus there are more being created all the time. So let's talk about which one is right for you. Well, I can't really answer that question. The key to determining the correct CPU for you is research. Now, when you're researching the purchase of a CPU, you need to consider what you are trying to achieve, as well as any budgetary constraints. As a rule, the better the performance of the CPU, the more it will cost. And the newer the processor family is, the more it will cost. Also, in most situations, the software that is available today can't take advantage of the full capabilities of the CPU. So you may not want to buy the most cutting-edge current version. But as the processor's performance increases, they develop software to take advantage of more and more of those capabilities. So which CPU is right for you? I can't answer that for you. You're going to have to be the one to do the research. Now that concludes this session on the introduction to the CPU. We covered quite a few CPU basics. We talked briefly about Intel and AMD CPUs. And then I tried to answer the question of which CPU is right for you. Now, on behalf of Pace IT, thank you for watching this session, and I'm sure you'll watch another one soon. Hello, I'm Brian Farrell, and welcome to Pace IT session on interface connections. Today we're going to be talking about internal interface connections, external interface connections, and finally some other optional interface connections that you should know about. And with that, let's go ahead and begin this session. So let's start this session with internal interface connections. Now, before I dive into this, I should mention that an interface is a connection point. It not only involves that connection point, but it also quite often involves the cable that goes with it. And with that, let's begin with the first internal connection, and that would be the IDE. That is the Integrated Drive Electronics interface. It used a 40-pin, 40-wire ribbon cable that could be up to 18 inches long, and it had 3 connections on it. 1 to connect to the motherboard and 2 for peripheral devices. The ends of the connectors were keyed so that they could only be inserted one way. Now, the IDE had a maximum transfer rate of 8.3 megabytes per second. IDE is closely associated with the Parallel Advanced Technology Attachment Standard, the PATA standard. Well, we found out that IDE just wasn't quite enough, so they came up with EIDE, the Enhanced Integrated Drive Electronics Interface. It used the same 40-pin connection that the IDE used, but it used an 80-wire ribbon cable. But it had the same physical dimensions as the IDE cable. Now, EIDE could achieve transfer rates of up to 167 megabytes per second. Man, that was a whole lot faster. EIDE is also backwards compatible with IDE. So now let's move on to SATA, Serial Advanced Technology Attachment. Now this is the interface that is replacing the IDE-EIDE interface in today's motherboards. It uses a 7-wire, 7-pin cable that has an L shape. Now that L shape means that it's a keyed connector and it can only be installed one way. Now this cable can be up to 1 meter in length. Now, unlike the IDE and EIDE interface, only one SATA device is allowed per cable. But all SATA devices are hot swappable. That's of questionable value if your hard drive is a SATA hard drive and it's inside the case. Now, SATA comes in 3 versions. There's SATA 1. It has a maximum transfer rate of 1.5 gigabits per second. Then there's SATA 2, and it has a maximum transfer rate of 3.0 gigabits per second. Then there's SATA 3, which has a maximum transfer rate of 6 gigabits per second. The other interface that you should be aware of is the eSATA, external SATA. Now this brings the high speed of the SATA interface outside of the computer case. Now it allows for a 2-meter long cable, and it can perform at SATA 3 level. Now that we're done with the internal interface connections, let's move on to the external interface connections. And we're going to begin with what's probably the most popular one, USB. The Universal Serial Bus Interface was introduced in 1998 and has been through several changes since it came out. The USB standard allows for chaining multiple devices together. You can chain up to 127 devices plus the controller. Now, the USB interface can not only provide a data bus, but it can also provide power to run small devices. Now, USB version 1.1 and USB 2.0 have a maximum cable length of 5 meters. But USB 3.0 does not have a maximum cable length, as long as the cable meets the electrical specifications. All USB standards are backwards compatible. Now let's talk about their speed. Now, USB 1.1 has a maximum transfer rate of 12 megabits per second. USB 2.0 was a vast improvement. It had a maximum transfer rate of 480 megabits per second. And then we jump up to USB 3.0. Now this has a theoretical maximum transfer rate of 5 gigabits per second. For USB 1.1 and 2.0, the standard calls for different types of physical connectors. They can be broken out into A connectors and B connectors, with each having a mini and micro version. USB 3.0 has its own standard for the connector. And these are usually colored blue so that you know that they're a USB 3.0. Now let's move on to FireWire. Now, the interface and standard were developed by Apple and introduced in 1999, and it has also been through several iterations. The FireWire connection was standardized by the Institute of Electrical and Electronics Engineers, the IEEE, as the IEEE 1394 standard. The standard allows for up to 16 devices to be chained together. The maximum allowable cable length is 4.5 meters. All the standards of IEEE 1394 are backwards compatible. There are two main standards. There's FireWire 400, which has a maximum transfer rate of 400 megabits per second. And then there's FireWire 800, which has a maximum transfer rate of 800 megabits per second. Moving on, we have the serial and parallel interface. These are the legacy standard for external peripheral devices. Most PCs no longer come equipped with these interface connections, having been replaced by the more versatile USB instead. Then there are the standard interfaces for connecting to external monitors. There's the VGA, DVI, and HDMI. That's the video graphics array, the digital video interface, and the high-density media interface. What is present on your PC will depend upon the graphics capability of that PC. Then there are RJ45s and RJ11s. These are the interface standard for twisted pair wires. Ethernet networking heavily relies upon the RJ45 interface, while the RJ11 is used with plain old telephone service, POTS. So now let's move on to other interface connections. These are non-wired interfaces. And we're going to begin with infrared. Now this is a line of sight interface only. The devices must be in visual range of each other. Now it uses the infrared band of light to communicate between devices. And it had a distance limitation of approximately 3 feet. And by today's standards, it was fairly slow. It's not very common anymore. And then we have radio frequency, RF. Now this encompasses various standards that involve communicating via radio waves. Your distance is limited by the power of the transmitting device. And your speed is limited by the standards that are employed. I'm not really going to get into that now. We'll get into that when we talk about wireless networking. Then we have Bluetooth. Now this is a low-powered personal area network standard, a PAN standard, for creating a radio frequency connection. It operates on the 2.4 gigahertz radio frequency. It has an effective range of 10 meters, but the transfer rate drops as the distance between devices increases. Now that concludes this session on interface connections. We talked about some internal interface connections, some external interface connections, and some other interface connections that weren't wired. Now on behalf of PACE IT, thank you for watching this session, and I'm sure I'll do another one soon. Hello, I'm Brian Farrell, and welcome to PACE IT's session on custom hardware configurations. Today we're going to be talking about custom configurations for work and custom configurations for play. And with that, let's go ahead and begin this session. So of course we're going to begin by talking about custom configurations for the workplace. And we begin with the standard desktop, the thick client. Now they should meet the recommended hardware specifications for running the proposed operating system. Don't just meet the minimum specifications for the OS or your users are going to be frustrated. The CPU should come from the mid to upper mid-range of the manufacturer's line of CPUs. For the RAM, your limitations are going to be caused by the operating system. A 32-bit operating system has a maximum RAM limit of 4 gigabytes, whereas a 64-bit operating system doesn't have that limitation. Now let's move on to the thin client. Now on a thin client, most applications and files are accessed and stored on servers, allowing the system to only need to meet the minimum requirements of the operating system. Even with that in mind, they should still also have enough capabilities to run basic applications. Now let's move on to a graphic or computer-aided design or computer-aided manufacturing workstation. This is a workhorse type system and should be built with power in mind. The processor should be more powerful and should come from the OEM's line that is designed for heavy workloads. They do have lines that are designed for workstations. These systems handle large files with a ton of data, so the maximum amount of RAM should be included with the system. These types of workstations also require at least one high-end or specialized video card in order to function properly. Moving on to the audio-video editing workstation, well, these are closely related to the design workstations that I talked about just a moment ago, with a couple of special considerations. Now, they require very large and very fast storage, especially for editing video. They also require specialized audio and video cards, and the video card or cards needs to be capable of driving at least 2 monitors. They still require more powerful processors and a lot of RAM. The virtualization workstation. Well, there are 2 keys here to this configuration, the CPU and the RAM. The CPU should come from the upper end of the power spectrum, and it should have as many cores as can be purchased and the client can afford. By the way, AMD's Operaton series of processors comes with up to 16 cores. Now, the maximum amount of RAM, random access memory, needs to be included. This is because each individual virtual machine will be held by and operate within the RAM. So it's all shared between the virtual machines, so you need a lot of it. Now let's move on to custom configurations for play. And we start with the gaming PC. Modern gaming tends to be about the experience. It also has some specific requirements. The CPU in a gaming machine should come from the high end of the consumer market. And because of the nature of gamers, it should also be capable of being overclocked. Modern games tend to be very graphics intensive, so at the minimum, an upper tier graphics card should be included, or 2 or 3. Well, sound makes up part of the experience, so including a good sound card will enhance the gamer's enjoyment of the system. Gaming and gamers tend to tax the PC, and the harder you run it, the more heat that is generated. So installing increased cooling capacity is also often required. So how about the standard home PC? Well, in most cases, the home PC has the same requirements as the thick client from the work configuration. Now let's talk about the home theater PC. In most home theater PC applications, the CPU and RAM only play a minor role, so their importance is minimized. This allows you to use a smaller form factor like an HTPC or an ITX-based system, which allows you to use a low-powered CPU, and you might not even need to install fans, which is often a requirement of the home theater PC. These systems do need to have improved audio capabilities, so you want to install a sound card that offers surround sound. They also require a TV tuner card. And finally, for best results, the home theater PC should have at least one HDMI output to drive a television. Now let's move on to the home server PC. It's often used for media streaming and file sharing. The CPU requirements are fairly minimal for this type of application. It's more important to have more RAM than a powerful CPU. The home server PC, especially when it's being used for media streaming, usually requires more and faster storage. Large, fast hard drives should be included. To improve your throughput for a media streaming PC, you might want to consider bonding multiple Ethernet channels to the network. This will increase your bandwidth from the media streaming PC. Now, the key to building any custom configuration is to understand what it's going to be used for. Be sure and talk with your clients to fully understand what their intended purpose is for that PC. You need to understand what is important to them. Also be sure that you and the client know what the budget for the project is going to be. You don't want to go over budget. You should also strive to make the system as future-proof as you possibly can and still remain within the proposed budget. Now that concludes this session on custom hardware configuration. We talked about custom configuration for the workplace, and we talked about custom configurations for play. Now, on behalf of PACE IT, thank you for watching this session, and I look forward to doing another one.